Hey guys, welcome back. This is day 2 of 30, and in today's video, I'm going to be using a button which turns off, on, off, and it's going to do this. But the only difference is now I'm going to be using delay, and then I'm going to rebuild it using millis, and I'll kind of teach you digital read and all of that using the button and how to circuit that. But yeah, let's get right into it. Okay guys, so after watching some videos, you're gonna need five things. You're gonna need a button, and you're gonna need a 10K resistor and a 220 ohm resistor. First thing and the breadboard. Not breadboard, this is the breadboard. You're gonna need a circuit, a like Omega, Uno, whatever. But first let's take a look at the button. What the button is, it has 4 things right here, 1, 2, 3, 4, and they're connected. So think about these 2 are connected, and these 2 are connected, and these 2 are connected. So think about it, if it was this way, it goes straight across. Let's see, I'll do it with the wires. It goes straight across and then cuts up like that to break the connection in the middle. And then this one is straight, so it's kind of like, pretend that's straight and that's cut up, so they're not connected. But then let's just say I press the button, that thing that tilts up tilts down and connects to the wire. Yeah, that's the best I could explain it. And since it can't really fit because you can't put enough wires or anything there, you have to put it in the middle. And as you can see, if you put it this way, it just can't fit. So you have to make sure it's always this way. Okay? Zoom in a little more for you to see. And then you're gonna take your ground pin and you're gonna plug it in to ground, and then you're gonna plug it into the minus because you need it for the LED too. And then you're gonna take this, and it depends if you're doing, since this is input, you can do input pull up, or you can just do input, and for this instant that's what I'm doing. So you use a resistor, you plug it into the ground, but if you were doing an input pull up, you'd use a resistor and put it into 5V. But basically, if you're just doing input, you would do if you're just doing input, you'd put the resistor into the 5 volts, and it would be the other way around. You know, like high, low. It would be low when you press it down instead of high when you press it down. But since I'm doing just input, it would be high. Then you're gonna take this, you're gonna plug it into your 5 volts, and then you're gonna take a white, blue, doesn't matter actually what wire you use. I'm just gonna use white for this instance. And since for my coding, I'm gonna use 10. Gonna look for 10, plug it in, and I'm gonna take this, actually not right now, then I'm gonna take this, and in the same spot I had my thing, I'm gonna take this, I'm gonna plug it straight into 5 volts. Sometimes I just spread it out so it doesn't look so close, because this looks weird like that, you know, but I might actually just so it looks a little less. Oh wait, I can probably take this and plug it in straight to 5 volts because this is the only thing that uses 5 volts. So we're gonna plug that straight in. Is that at 3 volts? Yes, it is. 5 volts, there we go. That's what it looks like right now. And then you're gonna take your LED. I actually forgot to mention that too, and I don't seem to have it right here. So 1 sec.
The next day.
You're gonna take your LED, now that I have it, and you're gonna put it anywhere. By the way, remember cathode and anode, I explained that. My anode is gonna be on this to the left side. Like that. And you guys already know how to connect an LED kind of, but if you forgot, you connect this back to ground. Oh, you can just actually take this. I'm gonna straighten it out real quick, because as you can see, it's very cold and like crinkled. There we go, good enough. And then I'm gonna bend it, then I'm gonna take this right from here. Oh, and it instantly did that again. Great. And I'm gonna plug it instantly. And I'm gonna put it right there. And boom. And then I'm gonna take the other wire. And you're gonna plug it in to any pin. I'm gonna use pin 9 for this instant. There we go. And yeah, that's how you do the circuit. So I already have the code. I'll redo it for you guys. But now I'm just gonna make sure this works, because I don't want to give you a circuit that doesn't work. Okay, it actually doesn't seem like it works. So good thing I did that. Alright guys, so I figured out the problem. It was that I had this here, and this thing right here was one over. But as you can see, when this is over, it'll just spam blank. And then when I move that over there, and then ready, eventually you'll be able to do this. And but it's when you hold it down, because I don't know how to do the other thing yet. But tomorrow or whatever, I'll be able to press it and it'll stay on or blink or whatever, you know? And I think that'll be pretty cool once I can do that. But yeah, so we're gonna do this. I could show you this in delay, or we could just move right on to millis, because delay kind of sucks. And what millis is also show you in the thing, but it's like a timer that counts milliseconds, so it goes up and up and up. But yeah, let's get to that now. Alright, so today I'm restarting this project from scratch and doing it properly. What we're building is a button-controlled LED that blinks using millis, not delay, which is way more important if you actually want to build real projects later. I'm going to write the code from top to bottom, explain what every line does, and then at the end I'll show you how it connects all together. So if you've been confused about millis or buttons, this should finally make sense, and I just learned it. So now we're gonna do variables, and I'm reading like I already did this, so I'll just tell you. So I need something to store time, and basically I need the previous time at 0, because later on it's gonna run, and then you need the interval, like the number of seconds, so something to control how fast it blinks. And then we're gonna need pins for the LED and button, and a way to track the LED state. So there are the pins, and millis basically runs off of milliseconds, like I was saying earlier, and I'll show you that later on. But tell me if you can spot it, the mistake I just did there. And it's unassigned long, because it can go a higher milliseconds using unassigned long instead of long. And now we're gonna set the pin mode. And so this is the setup. This only runs once. Here I'll start the serial. Well, set the LED pin as an output, And then I'll set the button pin as an input. And then here in a few seconds, I'll start the serial just for debugging the code and making sure everything works right. So serial.begin. It's pretty simple, just telling the Arduino what each pin is doing. So let's tell me if you can spot the mistake yet. And now we're gonna do the loop in Millis logic. So we're gonna add the current time. And current time equals Millis because that's the current time running. And tell me if you spot the mistake there. And stuff is consistent because it keeps it. It will never change the variable. And now we're gonna do, now then I'll check, has enough time passed since the last blink? And if yes, then I'll flip the LED state. On becomes off, off becomes on. I write that state to the LED, and I then will reset the timer, as you can see here. So I'll flip. So this is checking has enough time. So I do current time minus previous time is more than or equal to, which basically is saying has 1 second passed yet. And as you can see, I'm going to compile it, and I just realized what I did. So I'm going to put int, and then I'm probably going to change that to consistent, yeah, because I don't want that to change, just in case I accidentally do. And then, yeah, that's just like that because I don't have it plugged into my Mega, and I was using an ESP. There you go. Tell me if you found that in the comments, that error. And then I will run it again, make sure everything's okay. Just compiling, that takes a sec. Okay, so sorry this is taking so long. You can skip to the end if you want to, by the way, if you just want to see the code to write it and copy it down. But I'd appreciate it if you guys stayed and liked and subscribed. But at the end of the video, I'll tell you what happened. And now that it's compiling still, I don't know why it's taking so long, but there we go, and it's good. So now we're gonna write that state to the LED. So I don't know. Oh yeah, because I need the LED state, and I forgot that at the top from what I said earlier. Yeah. Yeah, no, sorry. From what I said earlier, ways to track the LED state, and then I need bool button state equals false because that's for the button. So I almost forgot about that too. I forgot about both of them. So now if I write this state to the LED. So LED state, exclamation point, and exclamation point basically flips the state. It's like, no, now it's this. So now it's equal to true. And then print, tell me, and then I'll do print LED dot-state. Tell me if you see the problem there. I don't even know why I did that, but yeah. See, and I'm bringing that below because I realized I don't need to write that there, and I can just switch that state to true. So there's no point. I was making a few mistakes because I did this a few days ago. Like I was saying in my shorts, I did this already, and so I could do it, but yeah. That's why, and my MacBook doesn't have any voiceover, so I have to voice record over it. But Now it's both true because button state. And then if we go down here, yeah, I made a lot of mistakes during this, and that's why the video is so long. You can skip to the end if you really want to, but I hope you guys stay till on. And if you made it this far, like and subscribe. If I get to 50 views, I might do a live stream on my robotic arm if I have enough money to get it. But yeah, I'll let you know there's something crazy. But now we're going to do button state. And that's the problem of earlier. Digital write, not print. I'm not printing it. I'm writing it. And then I'm going to digital read. Tell me if you see a mistake. Yes, it should go in the if. Because if digital read, pin, and then equal, button state, so true, and current time minus previous time, so both. You do two, like, of those and symbols. And then you can do digital write, LED state. So then when you hold it down, it'll keep going on, off, on, off. And as you can see, equal, because two equal signs, not one, because we're not switching a state. So button state, and then, and, current time minus previous time equals the interval. And then I can get rid of that, because I don't need that anymore. And now, I don't even need to do that. That was just my brain tweaking. But yeah, there we go. And then I make a few more mistakes throughout here. But this is the button logic. So I'll add the button. This part is important because I check if the button is being pressed. If it is, then I allow the blinking to happen. If it's not pressed, I force the LED to stay off. But we'll get into that a little later. And there we go. I'm compiling, making sure everything works. And yeah. Now I'm uploading and testing if it works on my blink, and it should, because basically what we have done. Actually, there's one more thing we're missing, and tell me in the comments below if you can guess that before, and tell me where it should go. If it should go in the if statement or outside of the if statement. You see here in a second, because I do make that mistake. Sorry, that's been doing all this uploading. I'm editing on CapCut, and it doesn't allow you to, like, clip in the middle. And I wanted to get this done today for you guys. I have schoolwork to do and stuff. But done uploading, and I can check because we already have the circuit built. So as you're doing this, you can check, make sure it works. And here's your task: to redo this from scratch without copying. You can look at all of this, but just don't copy. You can, if you really start to struggle, then you can go back. But here we go. Thinking that's the problem, but it actually isn't. That was completely correct. And yeah, so making a beat, and previous underscore time equals current underscore time, because now, since it's always going up and it's never going to stop, I need to set the previous time to what the time just was, so 1,000. So then in the next second, when you minus the previous time by current time, it'll be 1 second, if you understand. So it repeats on a loop, and if you notice what's wrong, it's because I only have that as one equal. So it's flipping the state, but it's impossible to do. So then I do that. And then I'm still thinking, why doesn't this work? And I thought, and I was like, oh. And then I did that again, what I just had for some reason. I have no idea why. But then I start thinking, and basically what I have to do is I have to put what it had originally. Like I said earlier, has to be what it was originally, because it has to be higher or equal to, because it needs the two things, but it might be just a split second higher, but it shouldn't. It's just in case, that's how you do the code. Higher than or equal to. So I think I paused here for a second. So let's make a beat again. Sorry that this is kind of boring sometimes, but I'm trying my best. Hope you guys enjoy, and want you guys to like and subscribe. It would mean a lot to me. But I almost want to tell you the surprise, but at the end of the video, it'll say. So. See, and now higher than equal to. I do that, check, and I'm like pressing, and I'm like, why isn't this working still? And then I realize, and I'm like, oh, tell me in the comments. Like I said earlier, previous time underscore time, and I said, does it go into the if or not? And guess where it goes? Into the if. But now I'm doing serial printer and Millis, because I'm like thinking, oh, maybe it's broken, because when I was doing this one time, it actually was broken and I had to restart my computer, but then it worked. So, and then this is also showing you how Millis works. So I'll upload it, setting the bits, or baud, not bits. Then if you go to serial monitor, you can see it's going up by a millisecond super fast. You see that? You can see that going back every millisecond, and every 1,000 is 1 second. Passing. And why this is better than delay is because delay stops the whole program. However, Millis is more like for multitasking, so it's good to learn. So like, I can do this, and let's just say I can, like, control a servo of the robot arm, but it can also control a sensor, and I need it to pause, but this one can't pause, or else it'll break or something. That's when Millis comes in handy. But then I think I just found out why. So, as you can see, and I should be, and then I put it in the thing. When I turn it on, it stays on. So like that, it turns off. But if it's on off, it goes like that. That's why I need an else if, because we don't want it to stay on when it's off. So let's get into that. Okay, like I explained in the video, I need an else if statement, and this is, so now if it's not pressed, I need to force the LED to stay off. So basically, button held equal LED blinks, button not held, LED off. And yeah, that's basically how I do it. So I need an else if. If statement is like if this happens, else if is else if this happens. So like if the if statement's not working, it goes down, and then if this happens again, basically. But then because it's different from an else, because else is just else digital print, there's not like I can't control, it only does it if I do that, you know what I mean? But now I'm going to do digit read button equal opposite of button state because I don't want that. So, yeah. And then digit read LED output, and then digit read LED false. Or in a little bit I'm going to switch that to LED state because I'm going to switch LED state equals false just because the code up there, it's like reversing, so to tweak it out, and I don't want to do that. It's going to take me a second to figure it out, and then I'm going to see, because I'm like pressing the thing, and it's like tweaking out, and it's because I need to LED state equals false, and then put that there, so then it turns the LED off. And why this works. Here's the key idea. Millis lets the Arduino keep running instead of freezing like delay does. So instead of wait 1 second, we're saying check if 1 second has passed. That's a huge difference. That's how you can later add more buttons, control multiple LEDs, or build more complex projects. Okay guys, I hope you enjoyed the video. Sorry it was so long. It was just the code because it was a big code. And sometimes the videos can be really short or long, but here's the final product. It's on, goes off, and here's the crazy thing that happened. My robotic arm came in. I know at the beginning, the video I might have said like and subscribe for robot arm. And if you made it this far, just please like and subscribe. It would mean a lot to me. But, that was because I posted it before I ordered the robot arm. Well, I made that, like, scene. But, yeah. Thank you guys for watching. And sorry the video was so long. That was just because of the code, like I said. But, yeah. Thanks for watching. Like and subscribe. And I'll see you in day 3.